So in today's video we're going to try and avoid the magic blue smoke with our new ESP32 Wroom 32. So in the data sheet, if we scroll down to the index page and we take a look at the electrical characteristics and the DC characteristics, here we can see, so when people look at the data sheet here, there's sometimes a little bit of confusion to whether it's 40 milliamps or 20 milliamps. What we're going to say, really it's 20 milliamps per pin if you are sourcing power from it. And if you are going to be low level sinking current, as they call it, it's 28 milliamps. So here you can see the ESP32 with an LED attached to pin 15 on the ESP32. Now the important thing is to protect your GPIO pin is we need to keep the current to below 20 milliamps. So we use a current limiting resistor or a voltage drop resistor, and choosing the right value is important. Now in this case here I'm using a 10k resistor, which is not going to allow me to show you it on this very well. So when I connect the leads here, you can see on the meter now we're getting a reading of 0.15, so it's less than a milliamp. I've now removed the resistor, which is not a good practice, and when I now put the meter across, you can see I'm getting nearly 15 milliamps. If this goes much above this, I will be seeing the magic blue smoke. Plus I'm also over voltage for the LED, which is possibly really meant to be around 2 volts for this size of the LED. So this might go up in smoke as well at some point. So when we are sourcing current, what we are doing is we're taking the DuPont connector from the S line out to the positive side of our LED. We then go through a resistor, then into ground. However, when we are sinking, instead of taking the 3.3 volts from the GPIO pin, we take it from an external 3.3 volts and then we return it to the GPIO pin to then allow us to control the on and off state using our software that way. So we're going to use Ohm's law to calculate the current drop resistor required. We're going to use R equals V divided by I, and then here you can see a typical range of forward voltages required for the different coloured LEDs. So in this case I'm going to show you working out the value for a red LED. We know the ESP32 will supply 3.3 volts. The forward voltage we know is going to be 1.8, so we need to drop 1.5 volts. And we also want to aim for around 15 milliamps. So when we do the calculation for the resistor, here you can see it comes out at 100 ohms for a red LED. For a yellow LED, you can see we've still got the same voltage for the ESP32, or the forward voltage for the LED is 2.1, so this time we need a drop of 1.2 volts, keeping the same value for the 15 milliamps, and we start seeing 80 ohms. So it's important to calculate these yourself to make sure that you know exactly what you are expecting the ESP32 to source. Obviously the other thing then comes into consideration is what value resistor is available to you from the range that is sold. Following these rules avoids the magic blue smoke.